Good morning, good afternoon, and good evening across the world, and welcome to Notes 2021. My name is Emil Eifrem, and I'm the CEO of Neo4j, and I'm super excited about Notes 2021. We have a really exciting day ahead of us with over 50 talks across 5 tracks all over the world. Notes 2021 is actually the 3rd year in a row that we're doing a big online hands-on practitioner event for developers and data scientists. And it feels a little bit back to the roots for us. Notes 2019 was all live. It was actually streamed primarily from this studio here in Malmö, Sweden. Today in 2021, I think we're all having a little bit of a Zoom fatigue. And so that's why 94% of sessions at Node 2021 are live. And we have live Q&A panels with speakers and community members and partners participating after the sessions. And the tracks are all structured in a streaming setup. So in other words, if you want to watch all the talks in the best practices track, for example, you can lean back and don't lift a finger. So it's 2021, and we definitely live in interesting times. And these times can remind you to reflect on what actually matters and what doesn't matter in life. And for us, for Neo4j, and for me personally, I'm reminded that graphs are more than just a product. They're an idea about how to make sense of the world. And as human beings, we know that everything is connected. We see it, we feel it. And we know that it's important to understand not just that things are connected, but how they're connected. There's value in relationships. There's value in personal relationships, like your family and friends. Probably the most important thing in life. Without them, nothing else matters. But there's also a huge amount of value in professional relationships, from pair programming with a colleague to broader cross-organizational collaboration. And there's value in conceptual relationships, where you use relationships to place ideas in a context so that you understand them. You understand where those ideas fit in the world, and thereby you understand those ideas. And of course, there's value in data relationships, which enable us to really easily express what the real world actually looks like in our data. And that, ultimately, is what Neo4j does. Neo4j takes that simple yet beautiful observation, the value in relationships, and it lets you put that into practice in your own software, in your own data. And it turns out that there's a huge amount of power in that simple idea. In fact, it's so powerful that this concept has given birth to an entire new class, a new category of databases, graph databases. And when we first started calling Neo4j a graph database, we were the only one. We coined the term, we put the word graph and database together. No one had ever heard of it. But throughout the last decade, the popularity of graph database has formidably exploded. There's a site out there called DB Engines, and it's tracking 350 database projects out there. And they're tracking a bunch of signals per database. Number of tweets, Stack Overflow questions, Google searches, LinkedIn skills, job postings, things like that. And they compile a score. And it turns out that graph databases have been the fastest growing category in all of data management for most of the last decade. And that's why folks like Gartner are saying things like graphs is the foundation of modern data and analytics, which is obviously a quite strong statement. But maybe even more mind-blowing is the following statement. Gartner is saying that out of all the inquiries that they get related to machine learning and artificial intelligence, half of them involve discussion of graph technologies. And so let's just take a moment and reflect on that. AI and machine learning, it's probably the hottest area in all of technology today. And half of the inquiries about that are about graphs. That's a pretty strong statement about the future of the graph technology space. So, super exciting times, and Neo4j, of course, is at the forefront of everything graphs. And here to tell you more about the latest and greatest in Neo4j, specifically the Neo4j 4.3 release, is Stu Moore from the Neo4j product management team.
Thanks for the intro, Emil. Today, I'm going to cover 3 of the many great new features in the 4.3 release that demonstrate how Neo4j continues to be the most trusted, high-performance database, enabling developers to get to relationships faster, anywhere. In the next 5 minutes, we're going to explore how developers can build, test, deploy with their enhancements for DevOps, run faster transactions on nodes and relationships with new relationship chain locks, and run faster, deeper queries with relationship and property indexes. So what's happening in the world of DevOps? As with all our releases, new Docker images have been published. And there's great news for those people using Helm charts from our labs. They're coming an officially supported product. Single server Helm charts will be available very soon, and charts for clusters will be available later this year. These charts make great use of improved Kubernetes integration, and there is enhanced observability with more metrics for Prometheus. Neo4j's relationship with the network is changing too. Now that Neo lets you expose a cluster as a single IP address with a new server-side routing, it makes it so much easier to build and deploy applications in the cloud using load balancers, orchestration platforms like Kubernetes, application stacks like GrandStack that make use of GraphQL, and client applications like Jupyter Notebooks and Bloom. For those customers with demanding client and application access requirements, use a combination of strategies, routing strategies with client-side routing as well. Relationship chain locks help reduce the number of objects that are locked at any one time when you're performing updates. This is really helpful when you want faster transactions and bulk updates on nodes with a very large number of relationships. Over time, as your application creates more relationships between nodes, more items need to be locked to ensure the data is consistent. Now, imagine adding a new follower to The Rock on Instagram with his 232 million followers. Now that is a lot of locking to update The Rock. And there's a very high probability that you'll want to perform updates concurrently. 4.3 now provides fine-grained relationship locking, which removes the need to lock a group of nodes and relationships. Behind the scenes, the storage engine is providing a level of abstraction on the user's view of the data graph, so that transactionally safe locks can be obtained on individual nodes and relationships. By removing the locks from the start and the end nodes, this means you can update The Rock with a new follower so much faster. Queries are becoming faster too, with the introduction of relationship and relationship property indexes that complement the node and node property indexes that are available already. These new indexes enable you to speed up deep queries on relationships and their properties and reduce storage I/O by reducing the number of hits on the database. Picture running the investigation into the Panama Papers to find occurrences with the same 2 directors involved in hundreds of offshore companies. We need to use a co-occurrence query that finds repeated engagements of the same officers in many companies. A similar query could be performed in the context of social media to answer which 2 people always comment on the same posts, which may imply that The Rock and Chris Hart are really good friends. Creating these new indexes is really simple and done in much the same way as other index types using the create index command. Simply specify the relationship type officer of and the relationship property role. In the Panama Papers, we are able to get the query to execute nearly 3.5 times faster with 73% fewer database hits. There's a huge reduction in storage I/O. So to recap, we have now seen how Neo4j can help your teams build, test, deploy faster with enhancements for DevOps, run transaction bulk updates faster where there are nodes with a very large number of relationships with our new relationship chain locking, and run faster and more advanced queries with indexes on relationships and their properties. There is loads more that we didn't have time to cover today. For example, how read-only replicas can provide unlimited scale for analytical and data science workloads. So please check out what's new with Neo4j 4.3, and don't forget, download 4.3. Thanks for your time. Now back to Emil to hear how Neo4j helps you get to relationships faster.
Thank you, Stu. Okay, the framing of this keynote is a blueprint for success. And one of the advantages that we have here at Neo4j is that we see more use of graphs in the world than anyone else on the planet. There are hundreds of thousands of developers and data scientists that are actively using Neo4j at any moment. And from observing those users, some patterns have emerged. And we've compiled those patterns into what we call blueprints. And we hope that these blueprints will be valuable to the broader graph community and might even serve as inspiration for how to become successful with graphs. The first blueprint is about building an application from scratch with Neo4j. From day one, from the founding of Neo4j, we've always said that the 3 benefits of graph databases is intuitiveness, agility, and speed. And really, speed, when you look back at the previous decade, is getting most of the limelight here. If you think about the classic use cases for graph databases, be it recommendation engines or fraud detection or identity and access management or master data management, customer 360, the classic graph database use cases, they really come back to the ability for graph databases to be more performant than other databases for traversing rapidly across connected data. And that's super, super valuable. But when you're building an application from scratch, 1 and 2, intuitiveness and agility, is really what it's all about. So what this allows you to do, the intuitiveness and the agility of the graph database, is to start with the user interface. And when we observe what people are doing with Neo4j when they're building projects from scratch, we see people doing that a lot. This allows them to keep the user in focus. You first figure out the initial user flows, and then you can rapidly describe the data behind them as a graph, your application graph. And this really comes back to that first benefit, intuitiveness. All domain models are actually connected. Whenever you've used a foreign key in a relational database, you've used actually a relationship that encodes a relationship in a relational database. Whenever you've used not just a scalar variable, but like a variable that is a reference to another object instance, right? That's actually a relationship, right? Whenever you've done that in object-oriented programming. All of these things describe relationships in domain models, and that maps really, really well to the property graph model. So that intuitiveness is really, really powerful in the early phases of a project. And it then maps up with the second benefit, because that schema, the data graph, which is backing your application graph, as it were, right? What's so powerful with the graph database is that you can easily evolve that schema as your application is changing. And if there's anything we know is that applications and business requirements are constantly changing. And that comes back to the second benefit around agility. Neo4j and the property graph model is schema-free, right? It's super flexible, it evolves easily, it isn't rigid and predefined static square tables. And combining these two creates a very powerful combination that allows you to turn your ideas into reality and into software in a rapid fashion. A technology, by the way, that fits hand in glove in this phase is GraphQL. And GraphQL is a favorite tool for front-end developers today to request data from the backend. And GraphQL fits in really well with a graph database. You can obviously hear it in the name. It's graphs all the way down. And to make that really easy to use, we recently launched a new library, the Neo4j GraphQL library. And that is an amazingly productive environment to make it super easy to use GraphQL in Neo4j. And in fact, simultaneous with launching this library, we also launched a contest, the Euler Idea Contest. And what this is a contest around ideas. And it's about taking ideas and turning them into reality. And maybe I'll lead into it this way. Alfred Nobel once said, "If I have 1,000 ideas and only one turns out to be good, I am satisfied." But you really only know if an idea is good once it meets the real world. That is when ideas turn from fantasy and maybe inspiration and enthusiasm into reality and value. And what Neo4j gives you is a platform for turning your ideas into reality. You can connect your ideas, you can explain them to others, you can use those ideas. And with Neo4j, you can take them as far as you want to or need to go without switching technology. And so we announced this contest a couple of months ago together with the launch of the GraphQL library, and we were going to announce the winners today at Nodes in this keynote. There are 3 winners, and in third place is Help Me, which is like a Stack Overflow, but for social good. You can ask for help, you can lend help to others, you can earn gratitude and create strong graph local relationships. In second place is SeedFundMe, which is a Kickstarter website for investing in small businesses that are ready to grow. And the winner, number 1, first place in the Leonhard Euler Idea Contest is none other than developers.z, which lets you find software developers in Zambia through easy links and recommendations. So I think of it like a LinkedIn for developers in Zambia, built together with Neo4j and the GraphQL library. We also gave out 5 Creative Idea Awards. And these awards highlighted really the breadth and the depth and innovation that are possible with graphs and GraphQL combined with Neo4j. So big congratulations to all the winners, and thank you to everyone who participated in the contest. Through this contest, in just 2 short months, hundreds of people exercised the agility and flexibility of this new Neo4j GraphQL library. And to tell us more about this library and other news from our developer productivity suite, I want to invite Anurag and Greg onto the virtual scene and tell us more about that. Take it away, Anurag and Greg.
Awesome. Thank you, Emil. I'm Anurag Tandon, Director of Product Management for Neo4j User Tools. And picking up on GraphQL, our original GraphQL integration came into being 4 years ago and have been incubating in Neo4j labs ever since. And I'm extremely happy that we now have an official GraphQL product, the Neo4j GraphQL library. It did take us a while to get here, but this new product now embodies those 4 years of learning, and a lot of thinking has gone into it. It's designed to get you started super quickly. Just literally 3 easy steps to get to an API. Create your type definitions, append some low-code boilerplate like dependencies, connection info, and then deploy your API. That's it. The library provides the best of both worlds, which is to give you the ease of GraphQL to get going, but then have the power of our Cypher query language to extend GraphQL when you need it. And what's more is that we have a recommended stack to get you started. It's called the Grand Stack, which combines GraphQL, React, Apollo tools, and Neo4j to give you from zero to app in no time. And just to make this more tangible, all you do is feed your app schema to the library in a set of type definitions. For example, I want to store movies that have titles and ratings. And the library then spins up an API which can accept GraphQL queries from your application. The API takes care of the translation from GraphQL to Cypher, and then spits GraphQL responses back to the client. So no backend specific code in your client, no GraphQL to Cypher resolvers for you to write, and no extensive boilerplate. And it's easy, but don't take my word for it. Developers who have played with this library love it. Here's a quote. There'll be more on our GraphQL library product and its features later on today in several sessions. But now over to Greg King, our PM for developer tools, to give you an update on some of the other tools.
Thanks, Anurag. I'm delighted to be joining you to tell you more about what we've been doing in DevTools to make your development experience with Neo4j as easy as possible. So really our mission here in DevTools is to serve you as developers to make everything you do using Neo4j as easy as possible, right from the beginning when you're new to Graph and Neo4j, through to doing initial data loads and queries, realizing benefits with your own data, through to building your skills and knowledge, learning more advanced features of Neo4j, right through to being an expert user, a Neo4j ninja, where you're using Neo4j as a seamless part of your development workflow. So what I'd love to do is give you a flavor of the things we've been developing in the last few months that talk to some of these themes. Over in the Neo4j browser, we've launched new browser guides that are easier to follow and run. So we now have guides in the sidebar and an index of guides that you can access and refer to. And these guides stay on the left-hand side, and you can run your queries on the right-hand side and really concentrate on the guides and the content in separate parts of the screen. So we're hoping that will really help new and experienced users alike make the guides easier to follow for them. The second thing in browser that we've released recently is what we're calling a reusable result frame, which allows you to iterate and refine your queries in situ. So we've noticed that for us and for users, there is sometimes a problem where result frames kind of proliferate and we have too many result frames that we don't necessarily need. So this new functionality allows you to edit an existing result frame, maybe correct a minor typo or keep making changes to a query until it's just right, and have that result appear within a single result frame. So that's a great thing that we've been getting lots of good feedback on. And the third feature in the Neo4j browser is the Monaco editor, which we're pleased to introduce, and is really, for most people know, is the new de facto standard for web code editors as used by VS Code. So from the beginning, this is giving us some real kind of power productivity boosts for power users. So things like being able to quickly comment and uncomment code lines with keyboard shortcuts, moving query lines around, code folding and indentation, and things like more advanced search functionality. And we've also taken the opportunity to make the syntax highlighting much clearer for Cypher readability. And this will also pave the way for future productivity boosts that we'll implement in the Cypher editor in future. Switching across to Neo4j Desktop, we've introduced sample projects. So if you are, especially if you're new to Neo4j and you want to get up and running with a sample project, with a dump file and some Cypher queries and maybe some guides, you can load those from a set of sample domains to kind of quickly get up and running and familiarize yourself with what's what. And then finally, in Neo4j Desktop, for version 4 databases, we've introduced support for the multi-database concept. So now within Neo4j Desktop, without going into Neo4j browser, you can create and delete databases straight from within the desktop UI. Please join me later today when I'll be giving a more detailed talk on all of these features and more. But for now, back to Emil.
Thank you, Greg, and thank you, Anurag. That covered a lot of ground and touched on a few of the tools in our developer productivity suite, which acts as a good lead into the blueprint now to conclude level 1. As mentioned, GraphQL is a very popular way for front-end developers to access data on the back-end and back-end developers to expose their domain to front-end developers. And the Neo4j GraphQL library fits right in there, and it's becoming a very popular way to slap a front-end on top of your graph applications. And then Greg mentioned a few of the developer tools like Neo4j Browser, and every single Neo4j shop I meet with are using them frequently on a daily basis. And then a lot of organizations already have existing BI tools, which is where the Neo4j BI connector comes in. And it allows you to generate reports in your favorite BI tool, be it Looker or Tableau or something like that. And then finally, when you're ready to deploy, Neo4j Aura makes it effortless to spin up either dev, test, or production databases. So put together, this is a very common blueprint that we see for building a graph-powered application. Speaking of Aura, a few words about that. So there really are two pillars to Neo4j Aura. The first pillar is Aura Professional, which is a self-serve database as a service offering. It was actually announced here at Nodes in 2019, so a year and a half ago or something like that. It's a very popular offering. It's currently running more than thousands. It's actually running thousands of databases, I should say. And you see a few stats here on the slide. Probably my favorite one here is it's running over 5 billion monthly queries, which actually, if they were evenly spread out, that's over 2,000 queries per second. So just like as we're watching this, it's handling tens of thousands of queries, right? And of course, the reality is that they aren't evenly spread out. They're coming in at peak loads. So a very popular offering, robust, up and running now for several years. The second pillar then is Aura Enterprise. And this is really for these mission-critical, large-scale, deep enterprise deployments, which Aura Enterprise has just become extremely popular with large enterprises. You see some of the names here on the slide: PwC, Sainsbury's, Levi Strauss, Dun & Bradstreet, all using Aura Enterprise to power their large-scale, mission-critical graph applications. It's available on GCP, the Google Cloud Platform, and we announced a couple of months ago an early access program for Aura Enterprise on AWS, which we expect to go GA shortly, actually. So that's what Aura looks like today, these two pillars. But I'm really happy to announce here at Nodes 2021 the third pillar of Aura, which is Aura Free. And so what this is a new tier of Aura that is free forever, up to 50,000 nodes and 175,000 relationship graphs. So you can use Neo4j Aura Free to get up and running quickly with just a few clicks. And then, as your application is growing, you have a seamless migration path to Aura Professional, starting at 9 cents an hour, all the way up to Aura Enterprise. And the great part about this is that it's actually available today. So you can go to this link that you see here on the slide, neo4j.com/Aura, and sign up today. So you can just go there. It's free forever, up to those 50,000 nodes, 175,000 relationships. Go there, sign up, and have fun. Okay, so that concludes kind of the first, we call it level 1, blueprint level 1. You're up and running with your application. You've iterated quickly. And that amazing, the productivity of that stack, it gets you to that V1 of your product, which is awesome. You now have users, and they get value from your product. And that means you also have usage of the product, which means that you also have data. And this leads us to the next level in our blueprint for success. Using that data generated by your users to better understand your new product and your business, and then very importantly, to improve your product. So how do you do that? Well, let's say that you have a social graph data set. Let's say that the application that we iterated really quickly on using GraphQL and all those other tools was some form of a social application where you have people, you can see the persons here, which have some kind of a location, a city and a country. They post to forums. Maybe they subscribe to those forums. Maybe they're moderators. Maybe they're just post to them. The forums contain posts, and those posts have recursive comments, right? Like a comment thread, type of a thing. And they end up getting tagged, right? So a fairly simple application, but actually deeply connected. All right, so you have that application, and you have those users generating data. What can graph data science tell you about that data? So let's look at a few examples, right? The first one is find your friends, right? So all of a sudden, we're zooming in on that person and the relationships between those people, the social graph. And then you can use algorithms like community detection. And that can help users discover people that they know or other people that they might like to know. And so you can embed that into your application to generate more of those relationships into your product. You can analyze the forums and the posts and the comment threads and things like that and discover buzz, like what's actually happening right now. You can use centrality algorithms, a class of graph algorithms, to find out what's central in your graph. And then you can look at the comment threads and you can figure out how can I drive more engagement, right? You can find the patterns that led the most engaged users, the ones who engaged the most in those comment forums, to become engaged, what led them to become engaged, and then lead more users down that path to ultimately drive more engagement. So that's a small sample of the truly awesome power of what GDS, Graph Data Science, can do. And here to tell you a little bit more about GDS and how GDS interplays with Bloom are Alicia and Anurag. Over to you.
Thanks, Emil, for that introduction. So I'm going to be talking today about what's new since the last notes in graph data science. And when we're talking about data science in Neo4j, just as a reminder, what we're talking about is answering questions with relationships between your data points. That can be queries in the database, it can be machine learning to find patterns or make predictions, or it can be visualization with Bloom. What I'm going to be talking about today is machine learning. So going back to basics, we can kind of divide that up into unsupervised ML, where you're looking for patterns in your data or anomalies or trends, and it's really driven by the data that you have. Or you can do supervised machine learning, where you're predicting a value, an outcome, a label. It's driven by the labels in your data. And so in Neo4j, that really breaks down into graph algorithms for unsupervised ML. And then supervised ML is a new capability that we've added in the last few releases. And so talking about graph algorithms first, because that's where we started, I'm really excited to tell everyone that we haven't forgotten where we've come from. Our commitment is to better, faster, more algorithms. So if we talk about what's new since last time we spoke, we've added new algorithms covering things from influence maximization to multi-label community detection to new similarity metrics. We've made the algorithms that we've had better. We've graduated them from the alpha experimental tier up into the product supported tier. We've re-implemented them, we've added more capabilities, we've made them easier to use. And as part of that, we've also made them faster. So Dijkstra and our pathfinding algorithms are 25% faster. PageRank in our last release is almost 90% faster than it originally was. And Notivec, an algorithm that I said we couldn't make any better, is 60% faster. So we're committed to improving the unsupervised techniques that we've always had. On the supervised side of the house, what we're really talking about is either predictions influenced by the structure of your graph, so using the algorithms to generate features to make better predictions with the data you already have, or we're talking about predictions about the structure of your graph. So enhancing your graph by making predictions about missing labels, missing relationships, getting more out of your data. And so what we're talking about, what we've added to Neo, is in-graph machine learning, the ability to classify nodes. So maybe you're missing labels and you want to predict who's a fraudster, and to predict links. So maybe you have a relationship that exists, but you haven't observed it yet, or it's going to form in the future. What's now possible is you use your input graph as your labeled data, and you can predict how your graph is going to change structurally in the future. In order to support this, we've added MLOps support. So we've added the concept of a model catalog. So you train your model and you store it in Neo4j, and you can version it, you can share it, and you can apply those models to new data as they come in. And Notes is our big community event, so we always like to talk about what we're doing for you. And one thing we've added in our latest release is we've increased the number of models that community users can train and store to 3. So it's now possible for you to train models using different embeddings and compare them, or train different types of models and use them simultaneously on your data. What that means is at the end of the day, Neo4j offers the only completely in-graph ML workflow, going from raw data to algorithms to generate features, training predictive models, applying those to new data, or storing, publishing it, and sharing it with your team. And with that, I'm going to pass it off to my colleague Anurag, who's going to talk about visualization and what's new in Bloom. Thank you.
Thanks, Alicia, and hello again. Humans and graphs are both inherently visual. Bloom brings the two together, regardless of the role of the individual. And as Alicia mentioned, data scientists use visualizations and data science together all the time. Analysts also love poring over data visually to look for answers. But that's not all. Developers want to visualize connections in their data, and managers want familiar interfaces so they can explore on their own and not have to depend on others. Bloom was built to provide that visual graph exploration and collaboration within and across teams. Here are just a few highlights of how Bloom has evolved recently. Graph search is uniquely about patterns. So we continue to make Bloom's search first experience better by suggesting proactive patterns or patterns proactively and reducing the need to type a lot. Visualization is the core value prop for Bloom, and we now offer the hierarchical layout, which helps in so many use cases. We've also worked on optimizations for better readability and space utilization. Exploration, finally, is all about focusing on the right data. With features like filtering and finding data in the visualization scene, Bloom makes it easy to explore your graph. I recommend you to check out the Bloom session to learn more. And with that, I send you back over to Emil.
All right. Thank you, Alicia and Anurag. That was a whirlwind tour of a lot of exciting features, and yet it just scratched the surface. So feel free to check out the deep dive sessions later today on GDS and Bloom if you're interested in these topics, and I hope you are, because they're absolutely fascinating. All right, now I want you to hear what using GDS in practice is actually like. So what we've done is we've asked one of the earliest users of GDS to join us here today in this session and tell us a little bit about their journey with their identity graph. Over to you, Cameron, from Meredith Corp.
Hello, everybody. Today I will talk about the development of a highly scalable identity graph of Meredith digital customers that transformed billions of page views into unique identity profiles by leveraging Neo4j's graph database software. I will walk you through how this identity graph came to be, the challenges with scalability that we faced, and how we overcame those challenges using a handful of readily available tools for Neo4j. I hope that by the end of this presentation, you will recognize the transformative power of thinking about data as a graph, and will know precisely which tools will allow you to go from thinking to developing a highly scalable production system yourself. But first, you might be wondering who I am. My name is Cameron Harmon, and I'm a data scientist for Meredith Corporation. I have a BA in mathematics from the University of Washington and a passion for computer science and graph algorithms. I've been working on Meredith's identity graph using Neo4j's graph database software for about 2.5 years now. The identity graph that I will be discussing is one of Meredith's proprietary technologies backing Meredith Data Studio, which is a suite of advertising solutions leveraging Meredith's vast proprietary first-party data and predictive insights capabilities to help inform our partners' marketing, product, and business strategies. While you may not have heard of Meredith Corporation, you're likely familiar with many of our brands. Meredith Corporation currently owns 40-plus brands with digital presence across the web and mobile device apps. From People to Parents, Entertainment Weekly to Real Simple, Meredith's portfolio of brands reach 190 million unduplicated Americans each month and 94% of all US women. More than being a leading content producer, Meredith's premier customer database and trusted brands allow us to leverage analytics to uniquely identify our consumers and provide programmatic targeting with a higher click-through rate than traditional paid outbound advertising. Digital analytics, it's a field that's constantly changing. Historically, the best approach towards understanding anonymous users has been through unique cookies tied to consumer devices. Cookie loss, device diversity, and increasing implementation of tracking protections within browsers have pushed analytics to the point that measuring unique viewers of content is fuzzy at best. This poses the question, how do we make cookies live longer, given that they're the only source of understanding for anonymous customers? The pursuit of an answer to the former question led to this rather unassuming little diagram, but this diagram is the core of our graph model. Ingesting more than 60 million distinct cookies per day from multiple data streams, these first-party cookies paired with concurrently appearing third-party cookies are then stitched together, creating distinct communities that, over time, are far more enduring than any single cookie could be. These communities are then identified and given distinct persistent IDs. While the core graph model is easy enough to understand, developing a robust production system does pose certain technical challenges. With more than 1.2 billion distinct cookies seen every month, one of the greatest challenges in taking our identity graph from proof of concept to a production system has been achieving scalability. With such large constant growth of the graph database, and the correlated increasing complexity cost of every operation upon the graph, our implementation had to be smart, efficient, and capable of scaling alongside the graph with minimal increase in total daily computation, despite the constant influx of data. From proof of concept all the way to our current production system, the discovery of revolutionary yet readily available tools has been fundamental to achieving our current degree of scalability. In 2019, we developed our first proof of concept, importing 3 months of data from only first-party sources. Through experimenting with this database, we determined our foundational graph model and developed a rudimentary import process. Later, in 2019, we rolled out the first iteration of our production system. While our original production system didn't have the necessary scalability to handle the increasing amount of data, since then we've achieved the needed scalability, with some of the most significant contributors being parallel execution of our cipher statements with APOC periodic iterate, development of several of our own custom Java procedures, as well as utilizing the highly efficient GDS library's weakly connected components algorithm. To reiterate, these are some of the primary tools we've leveraged to achieve scalability: APOC, or Awesome Procedures on Cipher, the relatively new Graph Data Science library that replaced the deprecated GraphAlgos library, and lastly, if an existing algorithm doesn't exist or you just want to take advantage of unique traits of your graph model, custom procedures can be implemented using the Neo4j Java API. To date, our current production instance is hosted on AWS EC2 and holds 32 plus months of data using over 9 terabytes of hard drive space. Our graph currently contains around 30 billion nodes, 35 billion relationships, and 90 billion properties. Looking back to our original proof of concept, with several billion nodes, ingesting a single day of data took more than 24 hours, with just bare bones processing. Today, with 30 billion nodes, our daily processing time takes a fraction of the proof of concept's runtime and has a host of additional features and processing. As a result of our identity graph, we were able to increase the average number of visits per profile by 612% for 25% of our traffic, a vast increase over traditional individual cookies. For just users active in the last 90 days, we have consolidated 877 million first-party cookies that previously would have been considered as unique individuals with different interests into 135 million profiles. Our average length of touchpoints for a user went from 14 days of lifetime per cookie to an average of 241.6 days per profile. Our current node growth rate is about 14 billion nodes per year. At the current rate, we'll have 72 billion nodes in 3 years. But lately we've been looking at adding additional data sources to further increase profile longevity and unite even more distinct user devices into individual profiles. It is highly likely that in 3 years, we'll have more than 85 billion nodes, and depending on the density of our additional data sources, we may have 100 billion or more nodes. Based on our testing and algorithm analysis, we're confident that even 100 billion nodes will comfortably fit within our current systems. I, among many, am looking forward to the future evolution of this project. The things that I hope you take away from this presentation are that APOC and GDS are powerful tools for achieving scalability, and understanding that viewing your data as a graph can be overwhelmingly transformative towards what you can get from that data, and that custom Java procedures are a powerful tool that shouldn't be underestimated. I'd also like to remind everybody that you can always seek help from the Neo4j professionals and active community members whenever you're struggling. Thank you, everyone. See the slide for my email and LinkedIn. Back to you, Emil.
Wow, great. Thank you, Cameron. As mentioned, Meredith was one of the earliest users of Neo4j GDS, and it's great to see just how transformative it's been for their business. So this brings us to our next blueprint, leveraging graph data science. And first of all, in order to leverage GDS, you obviously need the GDS library. So that's an obvious part of the blueprint. And then secondly, there's always data floating around in your organization that isn't yet in Neo4j. And for that, we frequently see people using the Neo4j connector for Kafka and for Apache Spark to get that data integrated into Neo4j so you can start using the graph data science algorithms on it. And then thirdly, to complete the blueprint, Anurag demonstrated this in the product announcement session. But Bloom is a really popular way to do really two things. One is to display the ultimate result from GDS to end users, which are typically analysts. But it's also, secondly, used as an interactive tool as data scientists are building out and training and developing their models with GDS. It's really powerful to be able to inspect the data with Bloom on a day-to-day basis. So you add that all together, and this completes the blueprint for leveraging graph data science. It's worth calling out that this is a really powerful concept. We're not talking about putting data in one bucket to build your applications faster for your developers, and then moving that over into your data lake or something like that to be imported into TensorFlow in order to get access to AI and machine learning powers. No, this is all running on top of the same platform. And that's an amazing thing. Like, you build your application with Neo4j as your operational data store, you get that developer productivity, and then on that same database, you can also run machine learning and AI algorithms. And that's an amazing combination. All right, we're at the third level of our blueprint, and to be honest, this is the best part. We got to the first version of our product, we sprayed some GDS magic onto it that drove up engagement, and now your product is really starting to take off. And so graphs got you this far, and the question that this blueprint addresses is, how can you scale with graphs? How can you be successful with graphs at massive scale? Well, first of all, you have to remember that graphs scale very differently than any other data model. And with graphs, you really prefer the replicated architecture as long as you humanly can. It's by far the fastest and the most simple way to achieve both scalability and performance with graphs. And you really want to achieve both of those things. You want to be able to perform really fast at scale. Luckily, Neo4j has had a really powerful replicated architecture for 10 years now. It's super sophisticated and really mature. And for at least 90% of the deployments that we see out in the field, this is fine. And with Neo4j Aura, you can scale up smoothly without downtime. And it's elastic, so if you don't need that peak capacity, you can just scale down. But if the scale does grow beyond the capacity of replication, you got to shard the graph. So let's have a little bit of a look of how other technologies actually do sharding. So if you look at a document database or a key value store, they shard by spreading out the data evenly across the shards in the database, typically based on some form of a hashing function. And then when the user wants to get the data back, the data knows exactly where to find it based on that hashing function, it quickly goes to the shard and retrieves the data from that shard and returns it back to the client. It's simple, it's fast, and it's scalable. Now, if we switch into the graph world, there are two main approaches to sharding a graph database. The first approach is called spray and pray. And this one reuses the same approach as from the other types of databases and spreads out the data across the shards. And when your access pattern is just put and get of a document or a record, that's great. But we know that graph queries follow relationships, sometimes one level deep, but frequently more. And when your data is randomly spread out, your queries slow down to a crawl because your relationships cross shard boundaries. Unfortunately, we see this approach popping up a lot these days amongst graph vendors because it's an easy path to get the checkbox of sharding. But the sad part is it doesn't work. Because the reason you're using a graph database in the first place is that you want to have fast performance on your graph queries. So that leads us to the second approach, graph native sharding. And here's what you do with graph native sharding. First of all, you invest in data modeling ahead of time. And then you get these magical properties. You get unbounded size. You get linear write throughput with increasing size for common write operations. And then you get constant read performance with increasing size. So that obviously sounds great. Now, let me show you what this looks like in practice. So let's have a look at that same application that we discussed in blueprint number 2. Some kind of a social graph application where you have people, they have profiles, they have a location, they belong to forums, they post to those forums, you have posts, you have nested comments and things like that. If you look at this data from a volume perspective, then persons really number in the billions. Even a site like Facebook, which has been around for, 10, 15 years now, they have 2.8 billion people on it. And 2.8 billion people is obviously huge, but for a database like Neo4j, it's actually not that big. But the forums, they're growing insanely fast. These are forums where people post on a daily and an hourly and sometimes on a minutely basis. So the question then is, how do we shard this? Well, we really have two different strategies. We have the person shard, and for that, the replication strategy is amazing. 3 billion people easily fits on one replicated shard. But the content, the forums, every day is a new day full of posts and comments, and for that stuff, we have many shards, keeping all the posts within a forum on the same shard. But with the split here happening across shards, we still need to maintain those relationships across shards. So each forum shard will get references to the person shard to maintain the integrity of those relationships. So this is now our pattern. The person shard has about 3 billion people, 3 billion nodes, and let's say that each forum shard has about 1 billion relationships. And once you've established the pattern, great. You can spin up however many of these you need. Do you want to create 10 of them? Fine, go ahead. No problem. All of a sudden, you have a graph with 3 billion people and 10 billion relationships. But enough talk. Now it's time to show you how it's done in practice, what this actually looks like running live. And to demonstrate that, I'd like to invite onto the virtual stage my friend ABK. ABK, please take it away.
Hello, and thank you, Emil. Let me go ahead and share my screen. What we have here is an application based on the social graph Emil just showed you. There are people, forums, comments, all of the data is represented here. For a profile page like this one, you can imagine the queries you need to fill this with data. We've got a dev tools built in here that I'll just pull up and we can take a closer look. Now, up here at the top, there's a network activity monitor along with a latency gauge that'll let us see the performance of the queries. Down on the right, you get an idea about the overall size of the database, and this live database is currently spread across 11 shards. That is just the one shard for 3 billion people and then 10 shards for all the forum content. On the left, you see a listing of all the page queries. This top one is recent posts of interest. It does what you think it might for a given user, and all of their tagged interests fan out across all of the forums and pull back the recent posts and then show that. I'll go ahead and copy that over to Neo4j browser and we can take a look at the query. So we're connected to the same Amazon instance, and I'll just paste in the query and give it a run. Okay, so we've got people and posts. That's perfect. Now let me just switch back over to the DevTools panel, and we're going to just blast this against the live database and take a look at the performance. All right, that's looking great. After a bunch of runs, quickly settles into low double-digit milliseconds. This is real-time performance. I like it. Emil, back to you.
All right, that looks fantastic. So what ABK showed us here was an application running against a big distributed graph database of one people shard with 19 billion nodes and relationships, and then 10 forum shards with about 1 billion relationships each, and a total of 11 billion nodes and relationships. He ran a real graph query several hops deep, and during sustained load, it returned in less than 20 milliseconds. But we said we could repeat this pattern as much as we wanted to. So let's do that. This obviously ran really well at 10 forum shards and about 10 billion relationships. So let's 10x that. 100 forum shards, 100 billion relationships. Let's see how it performs at that scale. Over to you, ABK.
Okay, we can do that. I'll switch over to a database that has 101 shards. There's still just one shard for all of the users and then 100 shards for the forum content. This is one giant database. I'll run the same query that we had before, and let's take a look at the latency. All right, settling into around 18 milliseconds. This looks really good. Emil, back to you.
Wow. Still the same latency at 10x the size? This is what we talked about up front. This is the benefit of graph native sharding. That's constant read performance, while we've not doubled in size, but we've 10x'd in size. So that's amazing. But let's try our chances. And you know what? Let's 10x again. Let's run with a 1,000 forum shard database and over 1 trillion relationships. All right, ABK, time to show what you're made of.
All right, fine, but you better approve my expense report this month. Let's switch to the next database. Okay, now we're up over 1,000 shards, which is a bit more than you asked for, but it also gets us over 1 trillion relationships, which is pretty cool. 1 trillion relationship graph distributed over more than 1,000 machines. This is really, really big. We're going to go back to that same query and see what the performance is like. Okay, here it goes. I mean, I know this should work. It's still amazing to watch it work. The latency looks great. This is real-time performance over 1,000 machines. We've been using that same query to compare performance, but we do have these other queries sitting here. Let's take a look at one of them and run it against this unicorn scale database. Here at the bottom, we've got recent messages by friends or friends of friends. That will reach out across the social network, then over all of the forum shards to gather up content. Let's copy that over to Neo4j browser to take a look. Browser is now connected to the same machine, of course, and off it goes. Cool, amazing. Now back to DevTools, and we'll see what the performance is like on that one. Okay, incredible. This is still double-digit millisecond response time, getting over 1,000 shards to respond to our query. Awesome to watch. Emil, back to you.
So, if I were to dream and imagine the best possible outcome, this is what I would think. What we've seen here is constant read performance as we grow 2 orders of magnitude. We first 10x'd and then we 10x'd again. That's what ABK just pulled off. With Neo4j 4, Fabric, over 1,000 servers, and a big ass AWS bill. And at the end there, he pulled out a graph global query. He didn't actually mention this in the demo, but the queries that he ran there towards the end are from what's called the LDBC. The LDBC is the standard benchmark for graph databases. And the queries are really designed to torture a graph database. So this query at the end there was not a softball, easy query. It was a deep, complex graph global query touching all the shards, over 1,000 shards. And it returned in less than 100 milliseconds. With the graph native sharding in Neo4j 4, Neo4j can stay with you from zero, from before you even have an application, all the way through thousands of servers and trillions of relationships. Now, we've all seen technologies with really bold claims that look great in slides and maybe even in demos, maybe even in live running demos, but they fall short in the real world. And obviously, there were some really bold claims here in the end. So the question is this too good to be true? Well, this is up and running live. And even more than that, we've open sourced the entire demo application, including the backend, the orchestration scripts, even the pre-generated data files. And it's available right now. So you just go to this GitHub repo and start playing around. Poke at it. Have fun. Let us know on the Neo4j community Discord what you think. So, we've stepped through 3 blueprints throughout this entire 1-hour keynote. And we've learned how to build better applications faster. We've learned how to draw out deep and actionable insights from your data. And we've learned how to scale beyond 1 trillion relationships. Individually, these are really powerful tools. And together, they create this exceptional platform, ultimately for tapping into the value in relationships. So thanks, everyone, for paying attention. I hope you found this useful. I'm going to stick around for the rest of the day. I will listen in on many of the sessions. I'll try to participate in the chat forums. And in fact, you actually haven't quite seen the last of me yet. I'm going to actually pop into the final keynote at the end of Nodes 2021. Because there's actually one more thing that I'm really excited to share with you. A massive announcement, actually. So please stay tuned for that final keynote. Thanks, everyone. Please enjoy the rest of the conference, and do stay tuned for that final keynote. Thank you. Have a great day.